Hello guys, welcome to my channel AK Tech Services. So in this video we are going to see how to create a CAD model for split muff coupling. Split muff coupling is also a type of coupling which is used to connect between two different shafts to transmit the power from one to another. So this split muff coupling is going to have two different parts which is going to as a split, and in this we are going to connect the shafts along with the help of keys and nut and bolts. So without any delay, we'll get into this video. To create this split muff coupling, I'm going to use this drawing as a reference as which I taken from a machine drawing. So the split muff coupling dimension has been derived with the help of the diameter of the shaft, which is mentioned as D. So in this case, I'm going to consider the diameter of the shaft D value is equals to 30 mm. So based on the diameter of shaft, rest of all the dimensions has been derived. So we'll start to create the model. In this, we are going to create three different parts. The one is the split muff couple, the second one is the shaft, and third one is the key. The shaft is going to have two quantities. Split muff is also going to have two quantities, as well as key is also going to have two quantities. Apart from this, we are going to have four different set of fasteners, which is nut and bolt. So let's see how to make this. I'm moving to the part once again. So here I'm going to create the split muff model. So to create the split muff model, first I'm going to click on the extrude command and I'm selecting the front plane, moving to the sketch view, and I'm going to create center lines for the horizontal and vertical directions. So next I'm going to create a center arc which is in a semicircle condition, and also I'm going to connect these two edges with a straight line. Now I'm modifying it to the diameter, and the total diameter of the split muff coupling is considered as 2.75 into D, which is 82.5 mm. So I'm modifying this dimension as 82.5 mm, and also I'm going to have an internal shaft dia also here, which is in the range of D value. This value is changes to diameter and the value is 30 mm. So I'm going to delete the unwanted lines which is here. So here we can able to see we have two different semicircles. One is 82.5 mm, which is the outer range of the split muff coupling, and another one is 30 mm diameter, which is the inner range of split muff coupling or the diameter of the shaft. So I just click OK here. Now I'm going to get extrude in the symmetric way for the total value of 3.25 into D, which is 97.5 mm. So this is the length of the split muff coupling. The next one is I'm going to have a hole to have a nut and bolts. For that, the material which is from the height is 0.5 into D, which I can able to show in the drawing. So here there is a dimension called as a 0.5 into D, where the height of the material from the bottom of the split muff coupling to the surface where the hole of the nut and bolt starts. So this height we are going to define as zero point 0.5 into D. So we'll move back to the part level. I'm going to create a plane with a distance of 15 mm, which is also 0.5 into D, or else we'll make a calculation here. 0.5 into D as 30, so we are getting 15 mm. So on this plane I'm going to create an extrude, moving to sketch view, and I'm going to create a circle here where the distance from the edge of the split muff coupling to the center is considered as D value is equals to 30, and the total distance between the one circle to another circle on the opposite side, the total distance is equals to 1.75 into D, which is 52.5. Here I'm going to have 52.5 divided by 2 because it is half of the value. The next value is the diameter of the hole. The diameter of the hole is considered as 0.9 into D. I'm going to have it as 27 mm. So just click OK here, and in this area I'm going to remove the material. So this is how the whole of this split muff coupling in one side has been creating. This is the same way we are going to have it on the another side. So just click on the extrude, click on the mirror command, and I'm selecting the plane here. select the extrude, select the mirror command and select the plane, so you will have it on the opposite side. Now I'm pressing the control button and selecting both extrude and the mirror which is on the bottom side. Once again I'm going to mirror it with the help of middle plane, front plane to get on the opposite side as well. So now the next part is I'm going to have a hole on this area. To have a hole, I'm already having an axis line here which is automatically created when we create this extrude. In this same hole axis, I'm going to have another hole with the diameter of 0.25 into d plus 2. The 0.25 into d is 7.5 and plus 2 is total 9.5. So I'm going to select the hole. I'm selecting the surface with holding the control button. I'm selecting axis also. So the diameter is 9.5 into d and the depth of the hole is through hole where it needs to the reaches to the opposite side. So the same way I'm going to repeat in the all four directions. So mirroring it as well as hold and mirror, hold the control button, select the mirror command, select the front plane, the same holes has been replicated on the opposite side. So this is how half of the split muff coupling has been created. In case if you need, you can add the edge radius or chamfer round in the edges and the starting area of the holes. So I'm going to recolor it with the help of a steel. In this way, the same half of the split muff coupling, I'm going to use it in the opposite side as well. So next we are going to create the part for a shaft. Let me rename it as shaft and click enter. So in this, I'm going to click on the extrude, select the front plane, moving to the sketch view, and I'm going to have a shaft. Before that, I would like to have a center line in the vertical as well as horizontal. I select the circle command, place it on the mid of the lines for the diameter of 30 and just click OK. I'm going to have this extrude of 100 mm and just click OK. And I'm going to have color for this shaft as in the metals as chromium. So or else like to have some other different metals like copper, gold, silver, steel. In steel I will select the one. Okay, so the same shaft I'm going to use it in the both the sides. In this I would like to have a key hole for key placements, so I'm selecting the extrude once again, having then this surface. I'm going to have a center line on the vertical side as well as in the horizontal side. I just select the center rectangle, select the edge point of this and make a rectangle here. The total width of the rectangle is 3 and this is a 6, so that we will get half of the value in this area. I'm going to click OK here and I'm going to make extrude until in the edge of the surface, and this is going to be as a remove material. So here you can able to see a key has been created. So the total width of the key is 3 mm and the height is 3 mm. So in this way, next we are going to create a key. I'm going to click on the new command, rename it as key, and here we are going to have a extrude in the front plane. Moving to the sketch view, I'm going to have a square which is 3 mm cross 3 mm. Okay, and that's for 6 mm. Just click OK, and this length is also I'm going to have for 50 or let me have it for 30 mm as of now. In case if it is needed, we can modify in the assembly area. Moving to the view command, for this I'm going to give a wood texture with maple wood. So I'm selecting this color, so this is going to be as a maple wood key. So the next part here is we have already created this, so I hope this is fine. In case if needed, you can have a key slot in the coupling as well, but mostly in split muff coupling it won't be there. I'm just adding for references. So the total width is, I'm considering 3 here and 6 here. Just click OK, and this is also going to be has two references in the opposite side of the surface and going to have a remove material. So this is how the coupling also has been created. Next we are going to have the assembly. So the first section part creation is done. Next we are going to the second section, which is assembly. So I'm making an assembly file here and renaming it as Split Muff Coupling and click enter. So in this first, I'm going to assemble for the first part, which is split muff coupling. In this, I'm going to have a pin connection. So as of now, I just click OK here, and I'm going to have access line based on the planes which we have already in the assembly workbench. So select the top and front, click on the axis, so top and right. Next top and front, click on the axis, and right and front, so click on the axis. So here we have three different axes. Then we are going to give an engineering connection for the split muff coupling. I'm going to have it in this direction, moving the connection type as pin type since it is going to run in the mechanism way. And I'm going to select axis to this to okay, the access is not available in the split muff coupling as of now. Let me create it as well. So I'm going to have a access based on this plane and this plane. So let me create a engineering connection, moving to the pin type, and I'm going to select the axis of split muff coupling to axis which is in the assembly. And for the translation, I'm going to have the front side, right side plane to right side plane as a coincidence. So the first half of the split muff coupling has been assembled. In the same way, I'm going to reassemble the another one. Insertion, I'm selecting the part. In this part, I'm going to use the axis which is already available in the split muff of the first part which has built here. So modify this. I'm selecting the pin type connection as the same. I'm selecting the axis to the axis of first part, and also I'm going to have a translation as from plane to plane. In this, I'm going to have another new set in the connection of general, so I can able to make the connection between the surface of first split muff to the bottom split muff as an equal one. So in this way, I just click OK here. So you can able to see we have assembled two different split muffs. One is on the top, one is on the bottom, with all the orientations, and the holes are perfectly matching. So the next part we are going to assemble here is the shaft. So click on assembly, go to insertion, I'm selecting the shaft, and the shaft is also going to be get assembled as pin connection. So select the pin type, select the axis line, and select the axis here. And for the translation, I'm going to have this right side plane to the right side plane to be as coincidence. So now I would like to show you the sectional view in the front side. So how half of the shaft has been connected in the one side. So next we are going to assemble the second shaft. For the second shaft, I just going to directly click copy paste here, but I'm going to reconnect all the connections from the beginning. So I'm going to have it by manual, and I'm going to have a pin type connection by the axis alignment as axis of the shaft to split muff coupling, and translation as the plane to the plane. But I'm going to flip this so that I will have the shaft in the opposite direction. And in general, I would like to rotate the shaft. Okay, let me deactivate the sketch section view. So in this shaft, I'm going to have another one set of connection, which is general, to have the keyhole of the shaft and the coupling to be get coincidence. So the final part which we are going to assemble here is the keyhole. So I'm going to select the key here. For the key, I'm going to have a general connection here where the surface to surface will get coincidence, and coincidence. And the last thing is going to have another connection in general that I'm going to connect this area with a distance of -30. So in the same way, I'm going to have the connection for opposite side key as well. I'm going to delete all the connections as of now, moving into general, and I'm going to select the surface of the side of the key to the surface of the key. Select this surface to, and another new set which will define the direction in z-axis. So this will be as -30. So just click OK here. So the next thing, I'm going to have the nut and bolt assembly also along with this assembly. So for that nut and bolt assembly, I'm going to the tools workbench where we'll have a screw and dowel options. So select the screw, select the axis where you wanted to position the nut and bolt, select the face of screw thread and select the face of nut and thread. So just click OK here. In this, I'm going to select fastener is ISO 14579, and I'm going to have M10 bolt here where it looks fine, and just click OK. So the total length of the bolt is not matching till the nut, as we can able to see in the section view here. Left side, yeah. So I'm going to increase the length of the bolt as 35, even more bigger 40. Yeah, 40 looks much good where the thread engagement is also fine and the clearance is also good. So just click OK here, and I'm going to repeat the same for all four sides. So I'm going to have pattern here. Sorry, not the pattern. I'm going to have kind of a mirror if possible. Okay, let me add it once again from the scratch for all the four sides. Just click OK. Just click OK. The same way, once again the opposite side. In case if you have the hole in the pattern way, it will automatically pop up a box where you wanted to assemble directly in all the holes where you have pattern. If you click S, what are all the holes wherever you have patterned the holes, in all the holes the same kind of nut and bolts will be get assembled automatically. So guys, I hope you have understand how to create a parts and assembly of split muff coupling in this. The next week we are going to see how to create a mechanism analysis for this. To see the mechanism, I'm going to the applications workbench, and I'm going to have a mechanism here, and I'm going to have a motor, but the motor I have already created here. So I'm going to just showcase how created motor for the split muff coupling with the profile details as angular velocity in degrees per second. So for the degrees of second coefficient value I have given as 10, and just click OK here. Now we are going to see how the split muff coupling is going to rotate. So I'm going to mechanism analysis, select the start time as 0, end time as 50, and click on the run command. So here you can able to see the mechanism rotation of split muff coupling is rotating. This is how a shaft as power has been converted or transferred from one to another with the help of split muff coupling. So I hope you have liked this video and understand how to create the parts, assembly and the mechanism of split muff coupling. If you really like this video, please hit the like button and please post your comments on the comment section. If you have any doubts or queries, you can post, or you can even post what the topics you're expecting as in the next video. And also please share with your friends who is very much interested in mechanical design, and we'll see you soon in the next video. Thank you. Bye bye.